Welcome to the Air Force Research Laboratory's Materials and Manufacturing Directorate. We invent the stuff that makes the future for the Air Force and the Space Force. Our mission's unique in that we have an outstanding cadre of expert scientists and engineers that push the state of the possible. We're here to ensure the materials are available, the very best materials for our warfighters, as well as the manufacturability, the inspection technologies, and the sustainability of those technologies, so that when one of our men and women in the Air Force or Space Force uses something, they have confidence that that technology is going to deliver what they need it to deliver.
The focus of my research is to develop practical quantum technologies. And so most of the quantum technologies, at least in the solid state, need to be cooled down to low temperatures in order to operate. And so the focus of my research is how can we get rid of the bulky cryogenics by controlling the noise that you get at room temperature, at high temperatures. We do that through theory, modeling, and simulation, and that's all done in conjunction with machine learning. We try to fabricate those results using techniques like E-beam lithography, and then we can go into the lab from there and test these devices.
For Air Force-related applications, specifically within my team, our focus is on developing mechanically robust polymers, as well as polymers that can withstand pretty high temperatures. I kind of come into play when it comes to processing these specialty polymers, where we need to scale that up for it to be used in additive manufacturing. With 3D printing, not only can we explore a diverse range of materials, we can also explore intricate design concepts. So with aircraft's components and different things that we develop, we have the ability to look at very intricate design and topology optimized shapes, which not only reduce our costs, but also can expand the applications of current products that we have.
Our group is focused on a particular class of materials known as 2D materials. We're particularly interested in new synthesis concepts and new processing methodologies that can enable sensors and electronics built off of 2D materials to be scalable. And so what we're interested in is using lasers or other light sources as a means to transform materials in a unique way. And in that sense, we can take lasers and locally pattern, crystallize, oxidize materials to create functional devices out of a film that is otherwise useless.
My research is focused on morphing aerospace structures. So designing morphing missiles is a really complex materials problem because we have to find materials that can both flex during flight in order to morph during the flight profile, but they also have to be rigid enough to withstand aerodynamic loads. No one material can withstand all of the conditions of the flight profile and the flight requirements. So we have to look at composite structures or combinations of different materials in order to withstand the different conditions. So this is a 3D printed model that actually shows how these articulated missiles work. So if this is a rigid missile, there's an articulated neck region that as the missile flies, it can actually bend in different directions to increase the range and maneuverability of the missile.
The focus of my research is specifically looking at how biology can be used to manufacture materials. We're looking at basically utilizing microbial organisms in order to make things ranging from specialty chemicals that could go into materials, for example, as monomers, all the way to things like concrete, where bacteria actually secrete cement and are used to make concrete materials that can be used to create infrastructure in remote locations. A lot of these processes have to be validated at the field scale, and doing that and setting up those tests has required us to figure out how to move beyond just growing up bacteria here in the lab and scale this up to tens or hundreds of liters.
What really drives my love of the Air Force Research Lab is in the purpose-driven research. And so you feel connected to the needs of the Air Force, and every day that we come in here, we're developing technology that can make a real difference in the world around us.
The collaboration here with other researchers is great because we're all driven by the motto, service before self. And so if you have a really great idea, it's really easy to just chat with your coworkers about your idea, and no one's really concerned about who gets credit.
We're here to support the warfighter and make sure that we're working on science and technology that we'll ultimately deliver to the warfighter, and we have that mission that sits beneath everything that we do.
In research and academic setting, you really are only working with people in your department. Here we get to work with people in all kinds of different specialties and backgrounds, and we get to work on kind of larger problems.
We also collaborate with a number of industry partners as well as other government agencies and as well as countless colleges and universities across the country. And it's really exciting to kind of see how everyone kind of comes together to kind of, work towards that one goal.
We're really excited about bringing together very diverse teams of experts across the spectrum, not only material scientists, but chemists, physicists, information technologists, data analytics, people doing AI, materials, automation, and design. Those are all the types of technologies that need to come together to ensure we can continue to develop new stuff that will make the future.